Buenos dias. It's a Dalek. Didn't Daleks look like that from Doctor Who? Right, folks. I packed up on the stars, didn't I? And then I've had this book for a while, so obviously started to look at this, and I'm torn how deep I want to go into this. I really, really am. Those of you who are listening seem interested, and what I will do is quickly read straight from where I left off, right? And then I might come back to this because it is something else, but there is something that you need to hear in this paragraph that's called the sister planets of the Earth. But that comes after the apparent wanderings of the planet. It's not a sculpture today. It's going to be a sculpture later on, but right now, not. It's a sculpture. Right. Now, right. Let's carry on from where I left off. Attractor, repeller, Dalek, Doctor Who. I am a Dalek. They only have one barrel. Right. The Earth and the other planets move in elliptical or oval orbits around the Sun. Because of this, we see each planet sometimes to the east of the Sun and sometimes to the west. The planets then appear to wander back and forth from east to west and from west to east. In fact, the name planet, which goes back to ancient times, means wanderer. When a planet is to the east of the Sun, it sets in the evening, just after sunset. When it has travelled part way around the Sun, in days, weeks, months, or even years, we see it to the west of the Sun, rising before sunrise. Yeah, all right. A brilliant planet in the morning sky is often called the morning star, and when we see it in the evening sky, we call it the evening star. The planets that are nearest to the Sun, that is, those that have the smallest orbits, Mercury and Venus, I presume, travel with the greatest speed. Therefore, they move from the morning to the evening sky more rapidly than do the planets with larger orbits. People often ask how to tell the difference between a star and a planet. The best way, of course, is to learn to know the constellations so well that you can immediately recognize the stars that belong to them. If you want to be able to differentiate between a star and a planet, the best way is to get to know all 88 constellations, and then you'll know if it's a planet or a star because you'll know everything that's in the sky. So here. In this way, you will instantly spot a planet moving through that part of the sky. It is a big help to keep track of the positions of the planets as they are given in popular astronomical magazines, almanacs, or newspapers. Another way, but not always a sure way, to tell a planet from a star is to watch for the twinkling of the stars. The stars twinkle under most atmospheric conditions, while the planets usually do not. Okay, now here we go, right? The sister planets of the Earth. Mercury is an elusive little body so close to the Sun that it never can be seen except for a short time in the dawn or twilight. Venus is the most brilliant of the planets, sometimes so bright that objects in its light cast a shadow. It was pitch black and Venus was the only thing out, but anyway, here we go. Ready? Mars, named after the Roman god of war, is red. Most people have been especially interested in Mars because in the past, astronomers have thought that it might be inhabited by intelligent beings. Now we believe that there is probably plant life of a low order on Mars, but no kind of animal life. In 1961, plant life. Probably plant life of a low order. 1961. Now, what happened to these super duper telescopes? 1961. 8 years before they went to the moon. They thought there was plant life on Mars, but they know. Here's a little bit of a crossroads for people. Does anybody think there's anything wrong with what's being said here, or standard? With everything they're claiming. In other parts of the book, everything. Plants. Claims of knowledge, right? That's all it is. They thought there was plant life. Not too sure. But the claims of knowledge on everything else, well, holy smokes, right? Now, this book, I could go into it because it has so much stuff, right? The sky is divided up into 88 areas, those are the constellations, then come in many different shapes. The tradition of dividing the sky into constellations began thousands of years ago when ancient peoples assigned certain star patterns the names of their gods, heroes, and fabled animals. With few exceptions, the star patterns bear very little resemblance to the people and creatures they are supposed to represent. The connections are symbolic rather than literal. It's good, right? So it goes on, and we get to a point where star brightness, right? Now, let's just, everybody presumes, okay? There's mucho presumption, too much presumption. Don't forget, this is 1985, right? Sun brightness, right? Star brightness are expressed in terms of magnitudes, abbreviated, no. This system was started by the Greek astronomer Hipparchus in the 2nd century BC. He divided the stars into 6 categories of brightness, from the brightest stars, first magnitude, to the faintest stars that he could see, 6th magnitude. 2nd century BC. Really? Telescopes? No, sir. The naked eye, he split all of the stars into 6 categories. Listen, here we are. Nowadays, star brightnesses are measured to the nearest hundredth of a magnitude by sensitive instruments known as photometers. A difference of 5 magnitudes is now defined as being equal to a brightness difference of 100 times. Consequently, each magnitude step is equal to the 5th root of 100, which is approximately 2.5. The 5th root of 100. Dun, dun. Follow that. Boom, straight away, everyone's left behind. Now they can say whatever they want. Right, the table, page 9, shows a difference in brightness that corresponds to a given magnitude difference. Stars over 2.5 times brighter than Mag 1 are given negative, minus magnitudes. Why not? They're brighter, we give them minus mag. That'll confuse everybody. I think they would say, well, the brighter it is. Sirius, the brightest star in the sky, which has a magnitude of minus 1.46. Stars fainter in 6th magnitude are given progressively larger positive magnitudes. The faintest objects seen through telescopes on Earth have magnitudes of about 24. The constellation charts in this book are down to mag 5.5. The total number of stars shown on them is approximately 3,000. Now, over there, weren't we told 4,500 yesterday? The Sky Atlas section of the book shows stars down to mag 4.5. Are they the bright ones or the dim ones? I can't remember. The brighter they are, they're in the minus. The magnitude of diffuse objects such as star clusters, nebulae, galaxies and comets is more difficult to quantify than that of a star. A diffuse object's brightness is usually given as though all in its light were concentrated into one star-like point. Therefore, a galaxy of 9th magnitude appears of the same brightness as would an out-of-focus star of a star of 9th magnitude, whose light was spread over the same area as the galaxy. The best way to estimate the brightness of diffuse objects is to compare them with the image of an out-of-focus star of known magnitude. But in 1961, they thought there was plants on Mars. There are several different systems for identifying stars, as a result of which we're talking about stars because it's all about space, isn't it? Flat firmament, stars, what are they doing? Where have they been? Where are they going? As a result of which a given star may be referred to in more than one way. Many of the brightest stars have proper names, which are of Arabic, Greek, and Latin origin. Examples are Altair, Sirius, and Regulus, respectively. Another common system is to give the brightest stars in each constellation a Greek letter. This system was started in 1603. 1603. By the German celestial cartographer Johann Bayer, so that the Greek letters attached to stars are known as Bayer letters. For example, Sirius is also known as a Alpha Canis Majoris, meaning that it is the star of Alpha in the constellation Canis Major. Note that the genitive form of the constellation's name is always used when referring to a star by its Bayer letter. Stars that are not identified in either of these ways may be given a number called a Flamsteed number, for example, 19 Lynches, because they were introduced in a catalogue compiled by the first English astronomer, Royal John Flamsteed, born 1646, died in 1719. Fainter stars are referred to by their numbers in any one of several star catalogues. The amount of knowledge that is, look, it's a story. It's a story. Various astronomers have also compiled specialized lists of particular types of stars, such as double stars, nearby stars, white dwarf stars, and these provide another source of nomenclature. Don't say that word very often. Nomenclature. And these provide another source of nomenclature of information, I guess. In this book, some double stars catalogued by the Russian astronomer F.G.W. Struve are referred to, what year? Any year? No year? Are referred to by their Struve numbers. Variable stars have a nomenclature all their own. Those that are not named under the existing systems are given one of two Roman letters. For example, W, Virginia, RR, Lyra. When all possible letter combinations have been used up, the variable stars in a constellation are denoted by the letter V and a number. For example, V 1500 Cygni. Are we following? Are we following so far? Good. This stuff, it is made to lose people. That's why it's made. But they're talking about it like they know all about it. And look, they don't know anything. They don't know anything. Objects such as star clusters, nebulae, and galaxies have their own systems of nomenclature. The most familiar, that's 3 times that word. The most familiar of which are the M and NGC numbers. The M numbers come from a catalogue of over 100 clusters and nebulous objects compiled in the 18th century by the French astronomer Charles Messier. Why not? Everybody else has had a go. The NGC numbers come from the New General Catalogue of Nebulae and Clusters of Stars, published in 1888 by Danish astronomer J.L.E. Dreyer. 2 supplements to the NGC called the Index Catalogues appeared in 1895 and 1908, 3 years after Einstein called the photon horseradish. Objects listed in these are given IC numbers. Some objects have both M numbers and NGC numbers. This right here it's just a trail. It's a joke. It is a joke. But there are people going, oh, you just don't understand. Understand? Are you listening? Stars are incandescent balls of gas, similar in nature to the sun, but so far away that they appear as nothing more than points of light in even the largest telescopes. Like angels. Nevertheless, by analysing the light from the stars, astronomers have been able to deduce that stars come in a wide range of sizes, temperatures, colours and brightness. The largest stars, aptly known as giants and supergiants, are hundreds of times the diameter of the sun, so that they would encompass the orbit of the Earth if they were placed where our sun is. Stars of such enormous girth are at a more advanced stage of evolution than our own sun, which itself will swell up into a red giant towards the end of its life. Rubbish. Claims, I've always said this, claims of knowledge that cannot be known. How on earth do they know that the sun is going to do one in 5 billion years? How? They've only been looking at the sky for 50 years with proper telescopes. How do you gain that much knowledge in 50 years? How can you call what's going to happen in 50 billion years after observing something for 50 years? They're looking into the past. They're looking into the past. No, they're not. No, they're not. During a solar eclipse, there is no light delay. I'm not even going to draw it on the board. You have the sun, you have the moon in front of the sun, and then you have the sweet spot shadow. When people are in that sweet spot shadow, it is the light source being blocked. It is the sun directly behind the moon, isn't it? So there is no photons. It's a myth. It's just more of the stupid. That's all it is. So what I was saying, what was I saying? Stars of such enormous girth are far more advanced stage of evolution. They're calling the sun going to do one in 5 billion years. How do they know? People think they've been looking into the past with telescopes. Light is absolute. Light is absolute. There is no light traveling towards anybody. If you turn a light on, how many times have I done this? It's almost common sense, for crying out loud. It really is. If I turn this flashlight on, right, somebody will see it maybe 10, 11, 12 kilometers. And then at 13, 14, they won't see it. They won't see it. The light doesn't travel towards them. Anything, any light source, it will radiate its light, bing, at absolute speed. Bang, 14 Ks. You have a person at 1 kilometer intervals, all 14 Ks, they all see it at the same time. Bang! You will not find a measurable distance between the first guy and the last guy. First guy, last guy. Wired in to a box, you turn the light on, the first person to press that button will be the person with the fastest reflexes, because the light, they see it at the same time. The bigger the light source, the further it will radiate its light at absolute speed. The sun, people on Pluto would see the sun at the same time as the people on Mercury. If it turned off, turned back on, whatever, there is no light delay. They don't look into the past with those telescopes. We all know about what we're doing. The James Webb Space Telescope at Lagrange Point 2 discovered the Lagrange points. Look, I'm getting off topic here. See what happens to me? All of it. All of it. It's just BS. They know a couple of things. They thought there was freaking vegetables growing on Mars in 1961, but they know all about the stars, don't they? They know everything, all the constellations. Vegetables, spinach growing on Mars. Right, look, I'm gonna have a break there. It is early. My head's not been too bad actually. I think it might have plateaued. 22. That will do. I will be back. I need to calm down. All right, later.